Hi everyone, the lesson for today is cofferdam. Therefore, at the end of this session, students should be able to number 1. Determine the type of cofferdam. Number 2. Identify the components of cofferdam. There are a lot of dams, and dams can be classified by its usage, such as number 1. Check dam. Number 2. Detention dam. Number 3. Diversionary dam. Number 4. Dry dam. Number 5. Saddle dam. Number 6. Storage dam. Number 7. Overflow dam. Number 8. Wing dam. And number 9. Cofferdam. And this is the focus of the lesson this time. What is cofferdam? Cofferdams are temporary structures used where construction is being carried out in areas submerged in water. They are most commonly used to facilitate the constructions or repair of dams, piers, and bridges. The aim of a cofferdam is to be as watertight as possible to create a dry area in which to complete the required building works, or at least to limit water ingress to a safe level that can be pumped away. Cofferdams must be able to withstand very high pressures and can create a hazardous situations if they are installed incorrectly. They are usually constructed using steel sheet piles driven into the ground and supported by internal braces and cross braces. Timber sheet piles, concrete, or a combination of materials can also be used. A cofferdam can be any shape. Its design will depend on the depth required, the required working area, soil conditions, fluctuations in the water level, and so on. What is the purpose of cofferdam? Number 1. To retain soil and water to provide dry working area for workers such as pile driving operations or when the foundations for piers and abutments of a bridge, dams, locks, etc. are to be constructed. Sometimes it is also provided to store water temporarily. Number 2. Cofferdam can be used as either temporary or permanent. What is the characteristics of cofferdam? Number 1. Cofferdam should be reasonably watertight. Groundwater or water lying above ground level should be excluded. Number 2. Materials for cofferdam could be earth, timber, steel, and concrete. Number 3. Cofferdam is constructed at site of work. Number 4. Cofferdam will depend on depth, soil conditions, difference in water level, and availability of materials. Number 5. The design and layout of a cofferdam should be such that the total cost of construction, maintenance, and pumping is minimum. Number 6. Cofferdam should be stable against bursting, overturning, and sliding under the floods and waves. There are several types of cofferdams. Considering the material used in the construction, cofferdam may be divided into the following categories. Number 1. Sandbag dike cofferdam. Number 2, earth-fill cofferdam. Number 3, rock-fill cofferdam. Number 4, single-wall cofferdam. Number 5, double-wall cofferdam. Number 6, creep cofferdams. And number 7, cellular cofferdam. Sandbag dike cofferdam. This type of cofferdam is useful if the depth of water is small. Cement bags are partially filled with a mixture of sand and clay and systematically laid around the area in course. When the depth of water is low and the velocity of the flow is low, this type of cofferdam is generally being used. This type of cofferdams are constructed using cement bags partially filled with a mixture of cement and sand and systematically laid around the area in course. This type of cofferdams are very economical, easy to construct and dismantle, and there is no uncertainty of the availability of construction materials. Earth-fill cofferdam. The earth embankment is built around the area to be enclosed. It is constructed in places where the depth of water is in the range of 1.3 meter to 1.8 meter. The velocity of the current is very low. The earth bank is carried about 1 meter above the water level. The top width of the bank should not be less than 1 meter and the side slopes in a vary from 1:1 to 1:2. The earth embankment should be built from a mixture of clay and sand or clay and gravel. In order to prevent the embankment from scoring due to the action of water, side slopes of the bank on water side should be pitched with rubble boulders. Sometimes sheet piles are also provided for to make the cofferdam more watertight. Rock-fill cofferdam. If the depth of water to be retained by the embankment of cofferdam is of order of 3 meter, stone or rubble is used for the embankment. This construction is adapted only if the stone is easily available in the nearby areas. The stones are assembled in the required shapes of the embankment and the voids are partially filled with earth and stone chips. On the water side, the rock fill is to be provided with an impervious layer of earth. Single wall cofferdam. As the name indicates, single wall cofferdam have only one wall. Typically, single wall cofferdam are built using sheet piles. Area to be enclosed is small and the depth of water is more than 4.5 meter to 6 meter. Timber piles known as kite pile are first driven deep into the firm ground below the riverbed. Depending upon the velocity of the current of the water in the river, the center-to-center spacing of the piles may vary between 1.8 meter to 4.5 meter. Longitudinal runners called wheels are then bolted to the guide. Steel or wooden sheet piles are then driven into the riverbed along the wheels and are secured to the wheels by bolts. The sheets on the two faces are braced by truss arrangement of struts. This helps in increasing the stability of walls against the water pressure. half-filled bags of sand stacked on the inside and the outside faces of the sheets help in increasing the stability of cofferdam. After the cofferdam is constructed, the water in the enclosed area is pumped out and the construction work is taken up. This type of dam is mostly adapted in the construction of bridges, particularly in the constructions of bridge piers, where the height of the water level is more than 6 meters and the construction area is less. The construction procedures include driving of timber sheets in the riverbed along the perimeter of the construction, within which steel piles are driven, maintaining equal distance using wheels. The wheels are bolted with connecting sheets on either side. To improve stability, cement bags or sandbags are put on both sides of the walls. After dewatering of the area, construction is executed. Double wall cofferdam. Its construction is essentially the same as that of a single wall cofferdam, except that in place of one wall, a pair of walls with a gap in between is used all along the boundary of the space to be enclosed. This type of cofferdam can be used in depth of water up to 12 meters. As the depth of water increases, the wall should be made wider in order to make it stable against overturning and sliding. The distance between the two walls depends upon the depth of water. At the top, the faces of the walls are connected by steel rods spaced at close intervals. To prevent the leakage from the ground below, the sheet piles are driven to a good depth in the bed. When the excavation area is too wide for starting for single-wall cofferdam, then a more massive cofferdams can be constructed by utilizing double layer of sheet piles walls. The sheet piles walls are tied together or can be formed into interlocked cellular cells filled with rock debris or earth infill between the sheet pile walls. This forms a massive self-supporting cofferdams that can keep exterior water at bay and the working area dry for construction works. Creep cofferdam. If the stream has a hard bottom, it is difficult to penetrate the guide piles or sheet piles. In such cases, creep cofferdam is used. If it is suitable to be used when depth of water is in the range of 10 to 20 meters. Used for wide excavation and rocky river bottoms. The sheet piles are supported by a series of wooden creeps. A creep is a framework of horizontal timbers installed in alternate courses to form pockets, which can be filled with earth or stones. The length and the breadth of each creep depend upon the depth of water and the current of flow. The framework of the cofferdam, which made from logs of wood, is prepared on ground and then floated to the side where the cofferdam is to be constructed. On the side of water, the framework is provided with sheet pile. Creep is then sunk to the position. The bottom of each creep is given a shape to fit in the variation in the surface of bedrock. The space inside the creep is then filled with stone or any other materials, so as to make it stable against sliding and overturning. Cellular cofferdam. These cofferdams are suitable for enclosing large areas. They are used for the construction of long-span bridge piers across wide rivers or in backwater areas. However, these cofferdams are quite expensive. When the height of water level is more than 20 meters, normal cofferdams become uneconomical on that condition. For such a case, cellular cofferdams are being used. There are two types. Number 1, circular cellular cofferdam. Number 2, diaphragm cellular cofferdam. Circular type cellular cofferdam. This circular type of cellular cofferdam has the advantage that each cell may be filled completely to the top before starting the construction of the next cell without causing any distortion to the shell of the cofferdam. Once cell is completely filled up, it can be used for the construction of other cells. Each cell acts as a self-supporting independent unit. Diaphragm-type cellular cofferdam. This cofferdam consists of a series of diaphragm of steel sheet piles connected. The straight diaphragm walls are connected to each other by steel piles arranged in the form of arch on either sides. The radius of the connecting arch is generally made equal to the distance between the straight diaphragm walls. After the cells are driven to the required depth, they are filled with earth, sand, gravel, or other filling material. In this type of cofferdam, as the diaphragm which separates the two cells is a straight wall, it is necessary to fill adjacent cells at approximately the same rate. If this is not done, the unbalanced pressure from the field will distort the diaphragm, which may result in the failure of the interlocks. In these respects, the circular type cofferdam has the advantage over the diaphragm type cofferdam because in the former, it is not necessary to fill the adjacent cells at the same time. Portable cofferdam, which considered as environmental friendly. Instead of using sandbags and earthfill, portable cofferdam can be used. Such available brand is called Dams. It is a patented water-filled cofferdams. It is made of a heavy-duty geotextile woven polypropylene outer casing that contains two side-by-side inner tubes. It is the effective water barrier dam leaving only a minimal footprint on the environment. It uses on-site water. It is portable and reusable. It is also available in different heights. It can be extended to any length necessary using the extension coupling system. It is flexible, easy to install, steer or turn precisely. There are factors influence the type of construction for cofferdam, such as number 1, the depth of water or soil. Number 2, the soil condition which influence the stability of the cofferdam. Number 3, the fluctuations in the water level which can cause hydrostatic pressure. Number 4, availability of materials for the constructions of the cofferdam. Number 5, working condition desired inside the cofferdam. And finally, number 6, whether the structure is located on land or in water. Economic height of cofferdam. The maximum height of cofferdam for which its total cost is minimum, known as the most economic height of cofferdam. Number 1. Depend on the depth of water. For low depth, earth-filled cofferdam can be used. Meanwhile, for high depth, sheet pile cofferdam can be used. Number 2. Depend on the current. For high current, sheet pile cofferdam can be used, which has higher seepage control capacity. Meanwhile, for low current, earth cofferdam or any other can be used, which has less seepage control capacity. Number 3. Type and period of work. For short duration of work, timber cofferdam can be used. Meanwhile, for long duration of work, sheet pile cofferdams can be used. Number 4. High and low tide level. Sheet piles must have top level slightly higher than that of the high tide level, so that even in the extreme case, water cannot over top of the cofferdam to achieve the dry working area. Basically, sheet pile used for cofferdam has 4 shapes. Number 1. Z-type. Usually used for intermediate to deep wall constructions. Number 2. Larson's or U-type. Usually used for applications similar to Z-type. Number 3. Flat or straight type. Usually used for field cell constructions. Number 4. Arch shape and lightweight. Usually used for shallower wall construction. Sheet piles may also have different types of interlocking system. Now let's look at this case study. It is the Burj Al Arab. The permanent cofferdam was built for the base of this building. The background. This building is located at Dubai, United Arab Emirates. It is the first 7-star hotel in the world. The start of Dubai New Vision, attracting new investment in areas outside the oil industry. It is 321 meters height from the sea. The construction comprises of 2 main phases. Number 1, the main island, and number 2, the building itself. The process of building the island. First, temporary tube piles were driven into the seabed. Then, temporary sheet piles and tie rods were driven into seabed to support the boundary rocks. Next, permanent boundary rock bands or rock armor were deposited on both sides of the sheet piles. Hydraulic fill layers were deposited between bands to displace seawater and form the island. There was no solid ground under the building. It just weak sand up to 180 meters deep. So it was decided to go with the friction piles. After that, permanent shed units were placed around the island to dissipate the actions of waves and for protections. 2-meter diameter and 43-meter deep piles were driven through the islands and the seabed. Next, excavations began in the island to remove the hydraulic field. A cofferdam was being built while excavating. 2-meter thick concrete plug slab was laid on the base of the island to prevent the base from popping out because of the sea pressure. Reinforced concrete retaining wall was also built. Then the constructions of the basement started. The construction of the island was completed in 3 years. Basically, cofferdam has several components such as number 1, sheet piling, number 2, bracing frame, number 3, concrete seal, and number 4, bearing piles. Number 1, sheet piling. Sheet piles are individual panels with interlocking connections that link the panels together, forming a single barrier. Sheet piles are widely used for cofferdams due to sheet pile structure strength, interlocking capability that provides a watertight system. Sheet piles are preferred due to their ability to penetrate many types of ground, thus achieving deep penetration which provides resistance to inward movement at the bottom of the excavation. The ability to achieve deep penetration in permeable soil also has the advantage of cutting off water infiltrating into the excavation. Number 2, wales. A wale is a beam that covers the top edge of the sheet piles around the perimeter of the cofferdam. Number 3, braces. It is used to maintain the structural integrity of the sheet piles around the circumference of the cofferdam by resisting the pressure of the outside water against the sheet piles. Cofferdams are generally made of steel to provide the strength needed to hold back water from a construction zone. The typical cofferdam, such as for a bridge pier, consists of sheet piles set around a bracing frame and driven into the soil sufficiently far to develop vertical and lateral support and to cut off the flow of soil and in some cases the flow of water. The structure inside may be founded directly on rock or firmly soil or may require pile foundations. In order to dewater the cofferdam, the bottom must be stable and able to resist hydrostatic uplift. Placement of an underwater concrete seal course is the fastest and most common method. Where the cofferdam structure can be built on a layer of impervious soil, which prevent the passage of water, the area within the cofferdam can be completely sealed off. Impervious soil is the soil which offers maximum resistance to the flow of water such as silts and clay. Where the soils are pervious, the flow of water into the cofferdam cannot be completely stopped economically, and the water must be pumped out periodically and sometimes continuously. A soil is said to be pervious soil if it offers minimum resistance to the flow of water through it, such as gravels and sand. An underwater concrete seal course may then be placed prior to dewatering in order to seal off the water, resist its pressure, and also to act as a slab to brace against the inward movement of the sheet piles in order to mobilize their resistance to uplift under the hydrostatic pressure. Generally, there are several items needed for the installations. Number 1, pile driving hammer. Number 2, vibratory of impact. Number 3, crane of sufficient size. Number 4, steel sheet piles which typically used. Number 5, H piles and or wide flange beams for the wheels and stringers. And finally, number 6, barge may be required. Now let's look at video showing the installation of sheet pile for cofferdam construction. Cofferdam construction sequence. For a typical cofferdam, such as for a bridge pier, the construction procedure follows the sequence. Step 1. Pre-dredge to remove soil or soft sediments and level the area of the cofferdam. Step 2. Drive temporary support piles. Step 3. Temporarily erect bracing frame on the support piles. Step 4. Set steel sheet piles starting at all four corners and meeting at the center of each side. Step 5. Drive sheet piles to grade. Step 6. Block between bracing frame and sheets and provide ties for sheet piles at the top as necessary. Step 7. Excavate inside the grade or slightly below grade while leaving the cofferdam full of water. Step 8. Drive bearing pile. Step 9. Place rock fill as a leveling and support course. Step 10. Place trimmy concrete seal. Step 11. Check blocking between bracing and sheets. Step 12. Dewatering. Step 13. Construct the new structure. Step 13. Continue the construction of the new structure Step 14. Flood the cofferdam. Step 15. Remove the sheet piles. Step 16. Remove the bracing. And step 17. Proceed with the backfill. Now let's look at video showing the cofferdam construction.
Way past the end of nowhere, all along the one-eyed plain, where the devil lies awaiting, and it gets too dark to rain, and it gets too dark to rain. Never go into the darkness, never ever leave my sight. There's just too many crazes. You can die just beyond the light. They say that Jesus saves. I've seen none of that down here. I see people with a hunger. I see people with a thirst. And I can see the jungle growing. Wolves huddled in the street. Are they just some hungry mouths to feed? Or the glitter end of the dream? till the river comes rolling, where the levee tends to break, where to walk the streets at night. Well, it's not a risk that you will take, 'cause it's cold, cold down on the river, but you can see the Memphis Belle. This ain't no scene from heaven, this could be seen as hell.
The design of a cofferdam depends on various factors such as number 1, hydrostatic head of water, number 2, dimensions of the area to be covered by the cofferdam, number 3, subsoil conditions, number 4, fluctuations of outside water level, number 5, possibility of erosions, number 6, floating logs and etc. As it is sometimes not possible to determine accurately the force due to these factors, the worst condition should be assumed in the design of the cofferdam to prevent its failure. It is thus clear that a purely theoretically designed cofferdam may fail for factors unaccounted in its design. It has therefore become necessary to combine practical knowledge or experience with the theoretical aspects in the design of a cofferdam. Prevention of leakage in cofferdams. The water enters the cofferdam in the two ways, namely by leakage through the sheet piling and by underflow. The measures employed to prevent the leakage in a cofferdam are as follows. If the entry of water is through the cracks of the rock, it can be stopped by pumping cement grout through pipes of about 10 cm in diameter. The materials such as clay, sand, ashes, and etc. may be damped all around the cofferdam to reduce the quantity of entering water. There are several factors to be considered in cofferdam design. Number 1. Scoring or undermining by rapidly flowing water. This could cause erosion of the bottom when in streams or rivers. Number 2. Stability against overturning or tilting. Number 3. Upward forces on outside edge due to tilting. Number 4. Stability against vertical shear. Number 5. Effect of forces resulting from wave, water, active earth and passive earth pressure. The loads imposed on the cofferdam structure by construction equipment and operation must be considered, both during installations of the cofferdam and during construction of the structure itself. Removal of the cofferdam must be planned and executed with the same degree of care as its installation on a stage-by-stage basis. Stability of cofferdam may influence by several types of imposed loads. Number 1. Forces due to hydrostatic pressure. The maximum probable height outside the cofferdam during constructions and the water height inside the cofferdam during various stages of construction need to be considered. Number 2. Forces due to soil loads. The soils impose forces, both locally on the wall of the cofferdam and globally upon the structure as a whole. These forces are additive to the hydrostatic forces. Local forces are a major component of the lateral force on sheet pile walls, causing bending in the sheet and axial compressions in the strut. Number 3. Forces due to current. With a typical cofferdam, the current force consists not only the force acting on the normal projections of the cofferdam, but also on the drag force acting along the sides. With flat sheet piles, the latter may be relatively small, whereas with Z-pile it may be substantial, since the current will be forming eddies behind each indentations of profile. Number 4. Forces due to wave. Waves acting on a cofferdam are usually the result of local winds acting over a restricted patch and hence are of short wavelengths and limited to height. Waves can also be produced by passing boats and ships, especially in a restricted waterway. Number 5. Forces due to score. Score of the river bottom or sea floor along the cofferdam may take place owing to the river currents, tidal currents, or wave-induced currents. Some of the most serious and disastrous cases have occurred when these currents have acted concurrently. A very practical method of preventing score is to deposit a blanket of crushed rock or heavy gravel around the cofferdam, either before or immediately after the cofferdam sheet piles are set. A more sophisticated method is to lay a mattress of filter fabric covering it with rock to hold it in place. In cofferdam construction, safety is a paramount concern since workers will be exposed to the hazards of floodings and collapse. Safety requires number 1, good design, number 2, proper construction, number 3, verification that the structure is being constructed as planned, number 4, monitoring the behavior of the cofferdam and surrounding area, number 5, provisions of adequate access, number 6, light and ventilations, and number 7, attention to safe practices on the part of all workers and supervisors. There are several advantages of cofferdam, such as number 1, allow excavation and construction of structures in poor environment. Number 2, provide safe environment to work. Number 3, steel sheet piles are easily installed and removed. Number 4, materials can typically be reused on other projects. Now, let's look at video showing the removal of sheet piles. That's all for the lesson this time, and thank you.